For my dynamic systems project, I created a physical mass spring system, which you can see to my right, and it's oscillated by a servo motor with a variable input. And so we can scale up the frequency of the input, and you'll notice that between 4.5 hertz and 5.5 hertz, it hits a resonant frequency. So there is 4.5 hertz right there, and then it hits 5.5 hertz and quickly dies off afterwards. And so my goal was to use that observed natural frequency to guess the mass or spring constant of the system, the physical parameters. So I'm going to push this out of the way so you can see the math. It's a simple mass spring system, and going through the math, it yields this transfer function. And so the most important term of the transfer function is the k over m, because that is equal to the natural frequency squared, and that's what we observed in our physical system. If we plug in the values that we observed, somewhere between 4.5 hertz and 5.5 hertz, multiply those by 2 pi and square them, it gives us bounds of 800 to 1200 for our k over m ratio. So theoretically, we should be able to estimate the mass given the spring constant, or at least have a range for the mass, and vice versa. And sure enough, when I measured the actual values, the spring constant is 75 newtons per meter, and the mass was 0.08 kilograms, which yields a ratio of 940, which falls nicely within these bounds. So the math does check out, and this system could be used to guess an unknown mass or spring constant.